This is lesson 3.5, which is scatter plots and lines of fit. Our essential question is, how can you use a scatter plot to describe the relationship between two data sets? Okay, so our first example is to understand association. It says, what is the relationship for each scatter plot shown? So the first one says temperature after sunrise. So we have hours after sunrise and we have temperature. And you can see that all the dots are close together, and they look like they're kind of starting to form maybe a line, and it's increasing. So you can see it's going up positively. So this we would call a positive association. Okay, and then this one you can see it's headed, oops, that's not very good. Headed down. So this one is a negative association. And finally, on that last one, there's nowhere I could draw a line that would show the trend of the data. So this we would say no association. And if you look at the content there, oops, I'm running out of space. Okay. If you look at it's hours after sunset and amount of rainfall. We know that those two things aren't connected, whereas the temperature and hours after sunrise or after sunset are connected. So when you're talking about two things that don't have any relationship, you're probably going to have no association. Okay, so our example 2 is to understand correlation. So how can the relationship between the hours after sunrise and the temperature be modeled? And so you can see in here that there's a line drawn in. We call that a trend line. So if you can draw a line that models your data points, then it means that a linear model would be a good fit. So if your points all kind of form together and you could draw a line that fits your data, then a linear model would be a good fit. Okay, so the last example is we are going to practice writing the equation of a trend line. So you can see it says what trend line models the data in the scatter plot. So you can see on the left we had just a random scatter plot, which was electric hybrid cars sold, the year starting in 2000, and then the number in thousands. Okay. So on the graph on the right, the trend line is drawn in. So when you're drawing a trend line, you're not connecting the dots like making a zigzag pattern. You're making a straight line that tries to balance the dots. So you'll notice there's 1, 2, 3 lines above the trend line, and there's 1, 2, 3 dots, sorry, dots, not lines, 1, 2, 3 dots below the trend line, and there's one that's kind of on it. So when you're drawing in your line, you're trying to kind of balance so that an equal number of dots are above and below. Okay, so now we are going to write the equation. So remember, an equation is y equals mx plus b. And so what you want to do when you have your trend line drawn in is you want to find 2 points, not points from the scatter plot, but points that are on that new line that you just drew in. So you can see the 2 points that they wrote out here, those are points that are blue because they weren't part of our original data set. But they go through nice corners of our graph. They go through the point 250 and 16,500. So the first thing I'm going to do is I'm going to find the slope. So the slope is how much am I going up, how much am I going over. So my change in y is to go from 50 to 500. So we think, how much did I go up to go from 50 to 500? I went up 450. And then how much did I go over for my x direction to go from 2 to 16? So from 2 to 16, I went over 14. So this would be 450 over 14, which is about 32.1. It's not a nice whole number, but we're just going to round. Okay, so now I have a slope, and I have 2 points. So remember, when we have a point and a slope, point slope, y minus y1, equals m times x minus x1 is a good model to use. So I'm going to use the point 250. I could use either one. And I'm going to say y minus 50 equals 32.1 times x minus 2. Now I eventually want my equation in y equals mx plus b, so I'm going to distribute the 31.2. So that would be 32.1 x minus, if I take 32.1 times negative 2, I get 64.2, negative 64.2. Then I'm going to add 50 to both sides. So my equation would be y equals 32.1x minus 14.2. Oops. So if we want to interpret what that means, the slope is going to tell us how much the y changes for every x. So we know x is years, and we know that y is the number in thousands of electric hybrid cars sold. So that means that there are 32,000 more cars sold each year. So 32,000 more electric hybrid cars are sold every year. So that's what that constant increase of our slope means. The y-intercept in this case is one that maybe doesn't make a lot of sense, because it would be how many cars were sold in the year 2000, and it would be negative 14,000. Well, we know we can't sell negative 14,000 cars. So probably what that means is that we weren't selling cars until a later year, and that's why, so even though we extend the line down to figure out what the y-intercept is, it might not make sense in this real life situation. Okay, let me know if you have any questions.